Today's going to be 34-6. We're going to take a look at trig graphs and cotangent functions. So we're going to graph cotangent functions today. Now this is basically what a cotangent function looks like. Now if you notice, it looks very similar to a tangent graph. And the difference is it looks it kind of got shifted over a little bit, and where my tangent graph normally does that, it's now going in the other direction. So let's kind of piece that together here. A few properties of cotangent. The domain, it's x such that x cannot be pi k. The range is still negative infinity to positive infinity. It's continuous and smooth. It's odd, and importantly, it still has that period of pi, just like tangent does. So this first one here, 2 cotangent of theta minus pi halves. Now remember, we have to just describe it. My amplitude, there is none. Now normally my tangent graph, we know that dad helps us graph this, so it's dot, asymptote, dot. And it has kind of like that image going on there. My vertical shift, there isn't any. My horizontal shift, we can find that in a little bit. And my period, we said it's pi over b, which is just going to be pi. Now we have to take this part of our function, theta minus pi halves, and we put that between 0 and pi. Now solving for theta, I'm going to get pi halves is less than or equal to theta, which is less than or equal to 3 pi halves. So that's going to be the first value. That's going to be the last value. And if I add these together and divide by 2, I'm going to get 2 pi halves, or just pi. Now normally, for tangent, dad is going to help us graph it. But now, with cotangent, it's going to be his daughter, Ada. And so now I know if I were to graph this, pi halves, 2 pi halves, and 3 pi halves, I know that at that pi halves is going to be an asymptote, dot, and then asymptote. And then the other thing is, now when I graph it, you have to graph it in the other direction. So this is what I did here. The first step is I set it up like I would tangent. I described it. I found all the basic information that would normally be on like a tangent. Then step 2, instead of being dad, it's Ada. So I switched the dots and asymptotes. And then when graphing it, I graphed it in the other direction. So normally, instead of going this way, it now went this way. And so that's why it was graphed in this direction here. Let's look at another one. Negative cotangent of theta over 2 plus 3. So now describing it, I know that tangent is normally dot, asymptote, dot, but, and so that would be like my tangent there. But I know that because it's cotangent, I'm going to have to switch things, and I can't forget I have a reflection over the x. I don't have an amplitude. No, my vertical shift is now going to be plus 3, so I know that my center line just shifted up 3 spaces, so I can't forget that. My period is going to be pi over b, and so that'll simplify into 2 pi. And my horizontal shift, that's typically the first value in the box when I find it. So now I take this theta over 2, and I put that between 0 and pi. Now solving for this, I need to multiply everything by 2. So times 2 times 2 times 2. And so I get 0 is less than or equal to theta, which is less than or equal to 2 pi. So I have 0, I have pi, I have 2 pi. And so here I have 0, I have 2 pi, that means that's pi. And so instead of dad for tangent, I need to switch the dots in asymptote, so it's asymptote dot asymptote. So asymptote dot asymptote. And then step 3, I normally need to graph it in the other direction, and so it's going to be graphed like this. But because of that negative, it poses a reflection, and so that's going to reflect. And so that's going to be my graph there. And I'll get rid of this just so it makes it a little neater. Well, this concludes our lesson. If you have any other questions, please leave them in the comments.